Dear students, in the previous exercise, we learned geometrical meaning of the zeros of a polynomial. Now, in this exercise 2.2, we are going to learn the relationship between zeros and coefficients of a polynomial. So, for a quadratic polynomial, if alpha and beta are the roots of a quadratic polynomial, ax square plus bx plus c, then the sum of the roots alpha plus beta is equal to minus b by a, minus b by a, and sum of the zeros is equal to minus b means minus coefficient of x divided by coefficient of x square. Now, product of the roots alpha into beta is equal to c by a. So, product of the zeros is equal to c is nothing but constant here, isn't it? So, c is the constant, c by a. A is the coefficient of x square. So, c by a, constant term divided by coefficient of x square. This is the relationship between sum of the zeros and product of the zeros. Now let us see the relationship between the roots and coefficients for a cubic polynomial. So if alpha, beta and gamma are the roots of a cubic polynomial, ax cube plus bx square plus cx plus d, then sum of the roots, that means alpha plus beta plus gamma is minus b by a. Then product of the sum of the roots, I mean product is alpha beta plus beta gamma plus gamma alpha, that is nothing but c by a, coefficient of x divided by coefficient of x cube. Then next one is product of the roots alpha into beta into gamma, that is equal to minus d by a. So that is constant term minus constant term divided by coefficient of x cube. So this is the relationship between the sum, the roots and the coefficients. Now let us see some problems from exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Here we have a quadratic polynomial x square minus 2x minus 8. So to factorize this polynomial, we split this middle term. So the sum of the two numbers should be minus 2 and the product should be minus 8. So if you multiply minus 4 and 2, if you multiply these two, we will get minus 8, and if you add, we get minus 2. So minus 4x plus 2x, we can split this as minus 4x plus 2x. Now let us take the first two terms, take the common factor outside, and from the next we should take the common. Here what is common in these two? X. If you take x outside, x minus 4 will be there. Here also if you take 2 outside, x minus 4 will be there. So 2 into minus 4 is minus 8. 2 into x is 2x. Now here we have two terms. X minus 4 is common in these two. So take x minus 4 outside, get x plus 2. Now what are the zeros of this factors? X minus 4 equal to 0 means x equal to 4 and x equal to minus 2. X plus 2 equal to 0 means x equal to minus 2. So 4 and minus 2 are the zeros of this polynomial. Now let us find the sum of the zeros. Sum, if you add these two, we get 2. Now let us verify the coefficient, relationship between the coefficients. So here we know that sum of the roots equal to minus b by a. Here b is minus 2. So minus 2 divided by a is 1. So minus 2 divided by 1, that is equal to 2. So here hence we verify the zeros and coefficients, relationship between the zeros and coefficients. Now let us find the product of the zeros. Product 4 into minus 2, that is equal to minus 8. Now here C by A, product of zeros equal to constant term divided by coefficient of x square, that is C by A, that is minus 8 by 1, that is also equal to minus 8, hence verified. Second question is 4s square minus 4s plus 1. Here the product of the two numbers should be 4 into 1, 4, and the sum should be minus 4. So we can take minus 2 and minus 2. When you add minus 2 and minus 2, we get minus 4. And when you multiply minus 2 and minus 2, we get 4. So let us split minus 4s as minus 2s minus 2s. Now we take the common factors outside from the first two. 2s is common. So if we take 2s outside, we get 2s minus 1. Here nothing is there. So let's take minus 1 outside. So we get minus 1 into 2s is minus 2s. Minus 1 into minus 1 is plus 1. So if you take minus 1 outside, this sign will become minus 2s minus 1. Now here 2s minus 1 is common in these two terms. So take outside, we get 2s minus 1, 2s minus 1. So s is equal to 1 by 2, 1 by 2 are the zeros. Now let us add these two. Sum of the zeros equal to 1 by 2 plus 1 by 2 is equal to 1. And when we find the coefficients, relationship between the coefficients, minus b by a. So that is minus 4 divided by 4. That is also equal to 1. When we cancel this, we get 1. So both are equal. Now let us find the product. Product of the zeros, 1 by 2 into 1 by 2 is 1 by 4. Here the constant term is 1. C by A, that is 1 by 4. So that is also equal. So like this we can verify the relationship between the zeros and the coefficients. 6x square minus 3 minus 7x. Let us rearrange this. 6x square minus 7x minus 3. Here the product of the two numbers should be 6 into minus 3 is minus 18. Sum is minus 7. So what are the two numbers? Minus 9 and 2. Minus 9 into 2 is minus 18. If you add these two, you will get minus 7x. Now let us take the common factors from the first two terms. 3x is common in these two. So 3x into 2x minus 3. And here in this term 1 is common. So you can take plus 1 into 2x minus 3. Here 2x minus 3 is common in these two terms. So 3x plus 1 into 2x minus 3. Now what are the zeros? 3x equal to minus 1. So x equal to minus 1 by 3. Here 2x equal to 3. So x equal to 3 by 2. So minus 1 by 3 and 3 by 2 are the zeros. Now let us add sum of the zeros equal to, take LCM. LCM denominator will be 6. Then 2 into minus 1. Minus 2 plus 3 into 3, 9. So minus 7 plus 7 by 6. 9 minus 2, that is 7 by 6. Next, let us verify the coefficient. Coefficient of x is minus 7. So minus 7 by 6. That is 7 by 6. Now let us find the product. Or let us multiply these two zeros. If you multiply this, we get minus 1 into 3 divided by 3 into 2, 6. So minus 3 by 6. C by A is also equal to minus 3 by 6. Hence verified. 4u square plus 8u. Since there is no common term, let us take the common factors in both of these terms. Here 4u is common, so let us take 4u into u plus 2. Now 4u equal to 0 means u equal to 0. U plus 2 equal to 0 means u is equal to minus 2. So what are the zeros? 0 and minus 2. Now Let us add these two. We get minus 2, and sum of the zeros equal to coefficient of u minus coefficient of u is minus 8 divided by 4, that is minus 2. Now let us find the product. Multiply. If you multiply these two, we get 0, and if you find the coefficient, constant term divided by coefficient of u square, constant term is 0, so we get 0 by 4 is equal to 0, hence verified. T square is minus 15. So t square is equal to plus or minus 15, isn't it? Now t is equal to plus 15 or minus 15. Now let us find the sum of the zeros. If you add these two, you will get 0. And coefficient of x minus coefficient of t divided by coefficient of t square, that is minus 0 by 1, that is equal to 0. Since t term is missing, so the coefficient is 0. Now let's find the product. Root 15 into minus root 15, that is equal to minus 15. Root 15 into root 15 is 15. So minus 15. Now coefficient of constant is minus 15 and coefficient of t square is 1. So minus 15 by 1, that is equal to minus 15. Hence verified. Next question, 3x square minus x minus 4. So when we multiply, we should get minus 12, and when we add, we should get minus 1. So what are the two numbers? Minus 4x plus 3x. So take x common outside, and from the last two terms we take, there is no common factor, so we take 1. Now 3x minus 4 into x plus 1. So 3x equal to 4, x equal to 4 by 3, and 4 by 3 and minus 1 are the zeros of polynomial. Now let us add these two. We get, take LCM, denominator 3, we get 1 by 3. Now coefficient of x by coefficient of x square, that is equal to minus b by a is equal to 1 by 3. Again product of zeros equal to, when we multiply we get minus 4 by 3, and constant by coefficient of x square, that is equal to minus 4 by 3, hence verified. Find the quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So what is 1 by 4 here? Sum of the roots, and minus 1 is product. So we know that sum of the zeros is alpha plus beta and product is alpha beta. Here sum is given as 1 by 4. That is alpha plus beta is equal to 1 by 4. Alpha beta is equal to minus 1. Now alpha and beta are the zeros of any quadratic polynomial. Then the quadratic polynomial equation can be written as x square minus sum of the roots alpha plus beta into x plus product of the roots alpha beta. Now we substitute these two values here, x square minus 1 by 4x plus minus 1. Here 4 is in the denominator, so take LCM, we get 4x square minus x minus 1 equal to 0 into 4. So we get 4x square minus x minus 4 equal to 0. Here sum of the roots is alpha plus beta is equal to root 2, and the product is 1 by 3. Alpha beta is equal to 1 by 3. So what is the general equation? X square minus alpha plus beta into x plus alpha beta equal to 0. Now let us substitute this, x square minus root 2x plus 1 by 3. Now let us multiply all the terms by 3. So we get 3x square minus 3 root 2x This 3 will get cancelled. So we get 3x square minus 3 root 2x plus 1 is the quadratic polynomial. 0, sum of the roots is 0 and product is root 5. So alpha plus beta is equal to 0 and alpha beta is equal to root 5. We know the general equation. Let us substitute this x square minus 0x plus root 5. So x square plus root 5 is the equation. 1 comma 1. So sum is 1, product is also equal to 1. So x square minus x plus 1. Alpha plus beta is 1 and alpha beta is 1. So this is the polynomial. Here minus 1 by 4 comma plus 1 by 4. So sum is minus 1 by 4. Product is 1 by 4. So let us substitute this in this general equation. So we get x square minus 1 by 4 into x plus 1 by 4. Now let us multiply, since the denominator is 4 in both, LCM is 4. So let us multiply everything by 4. So 4x square, here 4 will get cancelled, minus into minus is plus. So plus 1x plus 1 equal to 0 into 4, 0. So we get 4x square plus x plus 1 equal to 0. 4 comma 1. So alpha plus beta is equal to 4, alpha beta is equal to 1. So x square minus 4x plus 1 equal to 0 is the quadratic polynomial.